Hello everyone and welcome to the O-Piteco webinar from O-Pitblast. My name is Sarah. I'll be your host for this webinar. And we're going to wait a few seconds, let everybody get in. In the meanwhile, you can tell us who you are, where you come from. Create some engaging in the comments. We have our team ready to answer everything. In a couple minutes, Fabio will get in. He will be our speaker for the webinar. He's an environmental engineer. He's the mastermind of all O-Piteco. So any questions you have, you can also put it on the comments during the webinar. You will answer everything at the end. And just getting ready to talk about emissions control on Drill and Blast with O-Piteco. Hello, everybody. Hello, Alex, Paul. Hello. From China, Australia, Tanzania. Very nice. It's very good to see you all here to watch this webinar with us. It's perfect. Thank you. Johannesburg. Hello. From Portugal too. Macedonia. Welcome everyone. It's very nice to see you here. Thank you. Once again, for the people who are joining, you can ask all the questions in the comments. And Fabio is our environmental engineer. He's going to be our speaker. He will answer all the questions at the end of the webinar. So feel free to ask any question. We will get to them all at the end. Hello. All right. I can see a lot of people here. It's very nice to see all of you. It's perfect. Thank you. All right. We should start in a couple minutes. Once again, Fabio is our environmental engineer. He's going to be our speaker. Good morning from Italy. Hello. You will get in a couple minutes to talk about emissions control. Our new application O-Piteco is a sustainable app from O-Pitblast, and I hope it will help you in your operations and we can all be more sustainable together, which is very important for our environment. Good morning. From India, good morning. All right, so I'll see you at the end of the webinar. Fabio will come in now and don't forget to ask every question in the comments and Fabio will get to them at the end of the webinar. Please enjoy. I'm Sarah. We have our team of engineers watching this webinar and to answer you all on the comments, so feel free. And let's get started and I'll see you in a bit.
Welcome everyone, my name is Fabio Barbosa. and I am here today to introduce you to our project, O-Piteco. I would like, first of all, to thank you all for your presence here, and as well for attending this webinar. As Sarah said, and she did a wonderful introduction, thank you. We will be answering all of your questions at the end of the webinar, but feel free to type them in chat, and as soon as we can, we will come back to you. A little bit about me and about the progress before we get into the presentation. As Sarah said, I'm an environmental engineer, and I specialized into drill and blast emission control, and moreover into as well other mining operations emission control, and it has been the subject of my master thesis as well, and it has been my work ever since I joined O-Pitblast last year, so it has been quite some time since I've started to work on this project. So let's get into the presentation. Just give me a couple of seconds. Okay, very good. So first of all, this is a subject that is one of the common threads all over the world. Everyone is concerned about carbon emissions and about greenhouse gas emissions, and about how we should reduce them and how we have to care about them. And moreover, it has been something that has been spread, thankfully, globally, and now has come as well to the mining industry, and has come to put everyone up to grabs to be more sustainable and be more responsible as well. So a couple of reasons why are we doing this, and for those of you who might have not heard about carbon emissions and about greenhouse gas emissions and climate change before, basically all over the world, ever since the beginnings of planet Earth, planet Earth is a very special subject which goes through what we call a climate change every once in a while. The problem is that these climate changes usually take centuries or even millennia to happen. However, since humanity and society discovered industrial machines and discovered machines that emit, of course, a lot of emissions, this has been a process that has been accelerated a lot, and we are starting to face the consequences of this accelerated climate change. Even on the last couple of weeks, if you have been on the news, the fires in Canada, for example, are not only an indirect consequence from this, of the overall increase on the global temperature, but as well as if you hear about phenomena happening all over the world, for example, in the United States, several hurricanes were in places where we have never seen them, and scientists are still yet to prove, but we have strong beliefs that there are other natural disasters that are either directly or indirectly correlated to the accelerated climate change. So this brings us to the cause of all of this. The cause of all of this is what we call not only CO2 emissions, but carbon emissions. There is a natural flow of this, us as human beings. For example, every time that we breathe, we emit CO2. That would be okay if it was a regular quantity. However, since we have all of these machines and processes in place, because that's the nature of our society and nature of our technology, all over the world, depending on studies, every year we emit 35 billion tons of CO2, which is a very, very big number. And it is a number that goes into overflow of the whole natural cycle. Of course, this has been a problem that has been known for a while now, ever since last century, almost more than 50 years by now, at least. And of course, the governments had to reach an agreement, and they did several agreements, and the last agreement was the Paris Agreement of 2016. To explain this briefly, this basically means that as a society we have the compromise by 2100 to have the overall temperature of our planet not being greater than plus 2 degrees Celsius. So what does this mean? This means that on an overall temperature, if we are to compare the temperature of 2000 average, to compare it with the average temperature on 2100, the difference cannot be greater than 2 degrees Celsius. This doesn't seem like a lot, okay? 2 degrees Celsius doesn't seem like a lot. The problem is that we are talking about a whole planet, which is already very big. And it is the difference between we having, for example, Antarctica and up to the north, all of the ice, and not having it at all. And as you know, as you might have heard already from studies, there is a lot of things that have been on the ice, several diseases, several organic biology and other organisms that have been sealed by nature, and we do not wish that they come back, as well as another thing, which is if we melt all of this ice, then the water will overflow. And for example, from where I'm talking currently right now, in our office, which is almost, I wouldn't say level of the sea, but a couple of meters up, if that ice is all to melt, this place where I'm standing right now will be under sea. Moreover, for example, the Netherlands will disappear totally, because it is a special place, of course, which is already below the sea level. And even other places, for example, Australia will be almost all underwater, New Zealand as well, even Canada and the United States will suffer from this. So it is a thing that can happen globally. Here in Europe, for example, and even in Australia and Canada as well as other places, there are a couple of more goals that try to be more ambitious. For example, by 2030, we hope in Europe to reduce more than half of our emissions. And I would say that the green technologies contribute a lot to that. And by 2050, we hope to achieve what we call the net zero, which is if we do a balance on an overall year, we have to reach zero in terms of carbon emissions, which is a very, very good goal and a very ambitious goal, which will require, of course, a lot of work, not only from the industry, but from the society as well. Each and every single one of us can, in their day-to-day, do and have habits which can improve and can contribute directly to this and maintain, or almost maintain, our quality of life. Here at O-Pitblast, we believe in two things. We believe in the sustainable development, and we believe that the mining industry cannot only be an enabler, because we provide all of these critical minerals and materials to other industries and to other green sustainable technologies, but we can also be a leader, because we are, as you know, at the head. We are the beginning of everything. If anyone wants a smartphone, if anyone wants a laptop, if anyone wants to produce hydrogen, if anyone wants to do anything, you need materials, you need minerals. So we can show people how to be more sustainable in those two ways. And we can be an enabler, but we can also be what we believe we can be as a leader in this industry. We can show them really how to be more sustainable. This brings us to other responsibilities as well. I'll be talking a lot about carbon here, but there are other environmental impacts that are important as well, such as land and water life. Sustainable cities and sustainable communities, of course, depend a lot on this. I'll also be talking about more deeply into the other presentation about which environmental impacts are good to be considered. As well as, for example, I don't know if anyone is from the energy sector here, but if there is anyone, I think they can correlate to this. Clean and affordable energy is something that we, with our technology, can achieve. It will take time, and it is, of course, deconstructing an already very deep cycle, but it is definitely something that we can achieve, and with the technology and the pace of technology that we have right now, it will be possible in the future. As well as being responsible in our consumption and production, I'll be talking a lot about this when we go specific into the drill and blast industry, but even us today and tomorrow and for the days to come forward, we have the responsibility to consume and produce in a way so that our children and our grandchildren and even so on can reach same goals that we can achieve today. Let's say, for example, our grandchildren should be able to have a smartphone, for example. And we need to make sure that our grandchildren and so on can definitely have every luxury that we can have right now, and hopefully even more. So going specific into the drill and blast industry, what you can see right here is more than 1 year of studies being compiled together that we did here at O-Pitblast regarding the explosives industry, and we reached a conclusion that mainly on carbon emissions, production is responsible for more than 90% of the carbon emissions per kilogram of explosive. So what you see right here is, if you are to ask the carbon footprint, which is a way to measure the CO2 of 1 kilogram of explosive on this case, more than 90% of that is production. Of course, there are other processes as well, as you can see: transportation, charging, storage, as well as the own detonation, here painted on black. And this brings us to the main question. Okay, if 90+% in some cases is related to production, me as the end user, I don't contribute a lot. Although it is a whole cycle. We buy explosives, we buy accessories, we buy all of this in order to achieve the best of our operations. So we are also responsible for every kilogram of explosive that we use. And therefore, we have always to be achieving to improve our usage of the things that we use, because as you can see, every kilogram matters. So in order to do that, there is of course here a division between direct and indirect emissions. Indirect emissions being the production that I was talking about, and direct emissions being what we can control directly on site, the way that we charge, the way that we transport things, the way that we even detonate things. This is very, very important in order to reduce carbon emissions, but not only, improving the efficiency of our operations. And who does not like to improve efficiency of operations and having more profit with less costs? That's also very important. So we correlate everything: environment, society and safety, and economy. It's the three are the triangle that we are trying to optimize right here. This brings us then to the main point of our presentation, which is the O-Piteco. O-Piteco is, as Sarah said, and very well said, a web application that allows you to do the very big first step in reducing your carbon emissions, which is answering the question: okay, if I have more than 100 blasts per year, and I need to know, okay, how many carbon emissions or how much carbon emissions do I have? O-Piteco is the answer to that. It's the answer to the very big first step of having, okay, I need an answer to my carbon footprint. I need to know, based on my current operations, how are my carbon emissions. And I don't have 200 hours to be exploring every single site and every single blast in order to achieve this carbon footprint. O-Piteco comes directly to answer that. So it is a web application, runs on your browser, and it can work both on computer and tablet. And it comes comprised with 4 sections. I'll be going more later on this presentation, specifically on each section and how it works. But you can count as soon as you get and as soon as you have the software on a database with products and equipments that come from default. You can also introduce your own products and equipments into this as well. Then you have 13 different environmental impact categories associated with all of these products, including, of course, carbon emissions. And then you can do a whole summary of every blast that you have with the most important and detailed information. And then you can do, as a return, you can visualize all of your blasts and their own environmental impacts on different scales. So you can see per blast, you can see per project, and you can see even per week, month, or year even. Or even more. If you have 10 years of data, you can input 10 years of data and you can get exactly that return. We also have 2 mechanisms to treat carbon emissions. The first one being translating kilograms of CO2 all the way up to trees. Currently on the industry, this is a very big move. Companies, in order to access their own carbon emissions, they plant a lot of trees. And they need to access, firstly, a number of how many trees they need to plant. O-Piteco returns you exactly with this number, depending on the tree that you want, or on the trees that you want to be planted. Another very big thing is the carbon credits. Carbon credits is a thing that has been starting to grow very, very big. It's already a very big market with millions being invested into it. And it is a cap and trade system that works in two different ways. So the first way that it works is government programs. Every single government already has or will have its own program. But more or less the logic is you get a credit based on your own carbon footprint, and then you can use that credit, the money that you get from that credit, in order to invest into solutions such as O-Piteco, and then you get the return afterwards, of course, with certification. And if you are then to reduce your emissions, the credit will be sold itself, so you don't need to return the money. If you are then to fail, you will have to return the money. This is especially useful because there is a limited amount of credits, because there is a limited amount of carbon footprint. And not only for the mining industry, every single industry has access to this system. And what we can do in the application is do a forecast of how much your emissions are worth of. And who does not want to be paid for their carbon emissions? I think that's also a very big thing that people are going after, and they want to be going after as well. Being a simulation application, you can also optimize your own blasts based on the environmental impacts. Later on, as soon as we get through this first presentation, our second presentation is actually a case study that we did exactly doing this, optimizing Drill&Blast based on environmental impacts. Going a little bit more into the database, you can, as I said, you can have public and private data information as a cloud system behind it. So we go accordingly to the protection law of data, which is also a very big thing today. We want your data to be as safe as possible. Then you can define the whole cycle that you want to consider on your products and equipments. For example, and I'll be talking even more about this, but on explosives, we do have the production, transportation, charging, and detonation. You can customize which life cycle stages you want to be considered. If you only care about production because you are a manufacturer, you can only care about production. But if you want then to consider the whole cycle, you can also do that. Within a few clicks, it's very easy to filter the information. You can also leave comments on each product and each equipment. This will be especially useful if you have your own methods of calculation. So we try not to be strict with methods of calculation, because people all over the world have different ways to access their own figures, and they want to be able to use their own figures. So we can do that already on our application. And of course, because 13 environmental impact categories is a lot of data, and depending on your government requires or your agency requires, you might not need all of this information. So you can filter every single information that you want. And as well, in the end, you can compare different products and different equipments based on their own environmental impacts. This is especially helpful if you are looking forward, for example, to launch a new product on the market. One of the ways that you can advertise your own product is by doing exactly this comparison, and based on your own data and based on publicly data, okay, my product is sustainability superior. Going into projects, of course, you can create your own projects and blasts the same way that you create Windows files and Windows folders. It is exactly the same configuration and exactly the same idea, so that you can have an organization. It is not only helpful on environmental terms, but even on operation terms. It allows you a very good organization system. You can also customize blast properties. You can modify your drilling setup, your charging setup, and initiation setup on the fly. So it is something that you can do within also a few clicks. Then, of course, the main bread and butter of the application, which is, of course, the report. And the report allows you to see all of your emission results. It also already gives you an estimation on the trees and carbon credits as well. we do have this section separated, as you will be seeing, into two parts. We do have the screen part and the print part. So you can see them on your screen, but you can also take reports directly into PDF as well. Then the latest part of the application is the overview. The overview is where you can see an overall of your projects, and you can quickly access, for example, the whole carbon footprint of all projects and operations you manage or you participate into easily, just by within a few clicks. So the application will take everything that you have done and reproduce it in a very user-friendly way for you to be able to access this. This is especially useful if you are going to do presentations in conferences, internal presentations, external presentations, even for the administration of the company, for example. This is very useful for you to transmit in a very good way the information. And today, as you know, the world is all about communication. So this is one of the major steps that you can do in order to access that communication. So now we will be going to the case study, and I ask you give me a couple of seconds so I can transition my presentation. So just give me a couple of seconds. As well as doing the very important question, if you are ready to start enhancing the sustainability of your drilling and blasting operations. If you are, here are our contacts, our whole team. Feel free to contact any of us and we will be more than happy to answer all of your questions. So thank you a lot already for listening to this first part of the presentation. And as I said, just give me a couple of seconds for me to transition into the case study. Okay, very good. So this is our first case study with this application. As you can see, it was named a new approach to environmental sustainability in rock blasting. We do also have a blog about this in our website. So if you are curious, you can always check that out for more information. And if you have doubts, again, put them in the chat or contact us through LinkedIn, email, WhatsApp. All of our contacts are ready and available to you. So as I was saying, the main reason for this case study is because, as I said, even not only on sustainability and on green technology, but all technology today requires mineral resources. And overall, in the years, I would say that we extract more now than we did in the past. So there is a lot of pressure on availability on mineral resources, as well as an increase in the extraction of these mineral resources, and even new methods of doing this extraction as well. Us, as the mining industry, and if you recall that figure of 35 billion tons, 4% to 7% of that is us on the mining industry, depending on studies, but I can assure you at least 4% is our responsibility. So one of our key environmental challenges is, of course, this emission management. Not only that, but I'll be talking a lot about explosive here, but there is also other sources, of course. On-site fuel combustion, for example, is a very big thing as well. And not only that, but the detonation of explosives and the fumes that they produce, as well as the whole production and transportation of this, is also very important. And thus, until 2030, we have a very big goal of reducing our emissions, and we need to start at the beginning of the chain. Drill and blast is where everything begins, and is where everything will then go on. And if we optimize here, later on you will see increased gains, and you will see reduced emissions as well. So we kind of have our very big first step here in order to be more sustainable. As I was saying, and I've been talking a lot about CO2, another very big thing that we need to get to people is that CO2 is not the only thing that we care about. There is a lot of other things that we need to care about, such as methane, carbon monoxide and nitrogen oxides, for example. I can say to you, regarding greenhouse gas emissions, methane is also as important as CO2, although it is a lot more potent. So depending on the figures, it can be 25 plus times CO2. So the way that we do this on environmental science is that we get a comparison unit, which is called CO2 equivalent, that accumulates all of these gases into one unit. So it makes people's lives easier, so that they don't have to, wherever they go, they can compare their emissions directly and don't have to compare, okay, but I have X of methane, I have Y of CO2. No, you have X of CO2 equivalent, I have Y of CO2 equivalent. Let's investigate why. Am I doing worse? Am I doing better? This is the way that we can start, again, communicating with people. And that's I would say, the most important thing, communication. On carbon monoxide and nitrogen oxides, on the side note, these are also very important, not only on the environmental way of thinking about greenhouse gas emissions, but are also very important for safety. For example, carbon monoxide is very lethal. I think all of you might have heard this story or stories like this before, but usually this happens with old people in their houses where they have fireplaces, for example. They leave the fire on all night, they close all windows, and on the next day people died and no one knew why. It is because of carbon monoxide. Carbon monoxide on very lower doses is actually pretty lethal. So if you don't have correct ventilation, you will suffer from this. For example, a couple of years ago, I think 4 or 5 years ago, I went on a day to the fireman station, if I'm not recalling correctly, and the first thing that they told me on our training was, if you see a fire, you go down to the floor. And I asked why. Because of the fumes. Mostly on fires, what kills people is not the fire itself or the heat, it's actually the fumes. The fumes is what kills people. So it is very important that we are careful with this as well when we use explosives, mainly not only for open pit operations, but for underground operations where the ventilation is, of course, and will be a bigger problem. Nitrogen oxides are also very important as well. I'll be talking more deeply into them when we get to the acid rains and so on, but nitrogen oxides are also very, very toxic and are important that we decrease them as much as we can, because their treatment is a chemical treatment that's not very easy to handle and not very environmentally friendly as well. Going specifically again into the emissions from Drill&Blast, and I already showed this picture before, I just wanted to add a side note that depending on how we handle the explosives, we might need more and we might need less. What you are seeing here from production is mainly related to what we call the ammonium nitrate, which is a very big component on explosives nowadays, and technologies such as green ammonia or even peroxide hydrogen, for example, or other technologies will definitely come and help us with this problem by decreasing the carbon emissions, definitely. But it's always up to us and users to use the technology the best that we can. Going into specifically the environmental impacts, and here we have I think the most relevant and important ones. The first I've been talking already a lot in this presentation, of course, being the global warming potential. This is a way that we can evaluate per kilogram of explosive or per liter of diesel or per machine. We can evaluate how much carbon emissions we have. Then, of course, this all has a methodology behind. It's already a very old methodology in environmental science called the life cycle assessment methodology, which comprises all of these, which groups all of these environmental impacts and gives us a rate of how important they are to a certain industry or not. Another thing that's also important is, for example, if you have CFCs nowadays, it's thankfully it's way less because people adapted that technologies, and we started using a lot less other things that we used in the past that had a lot of CFCs. But it's also very important because even being lower, one molecule of hydrofluorocarbon is enough to destroy several ozone molecules. So the work that we did to repair the ozone layer is very fragile. So we need to be careful with those as well as the fact that we want ozone up there into the stratosphere. We don't want ozone on the troposphere, and we do not want what I call in chemistry the cousins of ozone being laid around and directly impacting our lives. For example, I am asthmatic, so I feel a lot when what we call the photochemical smog is on the air, and on cities this is very common, just with cars and factories working all over the place. And I immediately start to sneeze, I immediately start to feel anxiety, I immediately start to feel difficulty to breathe. And we do not want, I think all of us do not want a world where we have to go outside of our homes with a mask because we can't breathe properly. Nitrates is especially important for the next category of acid rains and acidification potential. I think everyone has already heard about acid rains, but for those of you who might not have heard, this is especially seen where in old monuments the rain starts to destroy them or starts to do cracks on them. That is acid rain directly. It is caused by components such as sulfur dioxide that then combine with water and generate acid, which therefore rains and not only harms environmental systems such as ecosystems, but also ruins our own constructions and our own monuments that everyone likes to see. So that's a problem, and we need to always be careful with our nitrate emissions exactly because of that. Another thing that happens is eutrophication. Eutrophication is, although it's a very hard word, it's not very hard to explain. When rivers get really green and you cannot see the water anymore, that's eutrophication. How does this happen? We supply with, for example, effluents, we supply a lot of ions which accelerate a lot of the growth of algae, for example, and other organical life beings that live in these waters and on land as well, although less common, and they start to grow a lot. And when they grow a lot, they of course consume oxygen, and when they consume all of the oxygen in the water, all the life dies, and then all of the organic mass comes up to the surface. That's exactly eutrophication. Explosives has a lot to say about this because when we detonate and when we blast, we need to be especially conscious with surrounding waters, with the wind even, and with surrounding land, because the rests of the explosives are the materials that have exactly these ions, and if they get untreated to waters, they will cause this phenomenon of eutrophication. I can say to you, here near Porto, where we are currently doing this webinar, we do have a very big river called I'll translate it to English, but it's called the Gold River. This river used to be very clean many years ago, but the industry has caused it to be what it is currently, a very dirty river, exactly for this matter of eutrophication. So it is a very big problem that's near to us as well. And then the latest two can be combined into one. They are the abiotic depletion potentials, which seems also a very hard word, but it is only a way for us to translate, especially for the energy sector. This is how much energy we get out of land, translated into energetic terms. So every time that we drill and we blast, we are taking away something from Earth in terms of energy. And following the whole cycle of energy is very important that we keep track of this as well. Going specifically into the case study, we compared three different sections, and we compared three different explosives, so that we can do exactly what we were proposing to do, which is reducing the emissions from drill and blast. So our setup here was Fordin produced in Finland, which was our booster, and then we compared three different emulsions: Hydromite 100 produced in Sweden, Chemiti 510 produced in Sweden, and Chemiti 810 produced in Sweden. As you can see right here, these are the carbon footprints for the production itself alone, and as you can see, per kilogram of explosive we have more than 1 kilograms on average being produced. This includes, of course, all of the raw materials procurement, transportation from factory to warehouses, store process, depending on if you need to package it or not, especially here for Fordin, it's also a very big thing. All of the production processes, which are different from factory to factory, fuel consumptions, are also very different. Electricity uses as well as cooling processes, among others. All of those have been compiled into the figures that you can see right now on your screen. Of course, being translated again into CO2 equivalent so that we can directly compare them. Then we had to, of course, also take into account transportation emissions. So we chose an operation site that was near Karlskoga, Sweden, 50 kilometers. Our explosive distribution center is also in Karlskoga, Sweden. Our forwarding comes from Hanko, Finland, and it is an overall distance of almost 2,000 kilometers, so it has to travel a lot to get into site. And then our Hydromite 100 is produced in Gatorp, Sweden, which is from Karlskoga 37 kilometers, almost 40. And then the very big thing was that Kemitti 510 and Kemitti 810 were already produced in Karlskoga, Sweden, so they went directly from factory to distribution center. In order to access the vehicle emissions, we had to consider, of course, fuel consumption, which depends on a lot of factors, depends on the type of the road, type of engine, tires, brakes, depends also on how old the car is, and every single one of these factors has been taken into account to do this emission factor, as well as the distance, of course. The higher the distance, the higher the emissions. Then what you are seeing right here is the direct application of all I have been talking about into the O-Piteco. So we applied directly all of these emission factors directly into O-Piteco, as you can see on your screen, and we consider them for both the explosives as well as the drilling machines. On the drilling machines there were other inputs, of course, the speed at which the drilling, of course, has to drill, the power of the drill, the energy factor, the emission factor for the fuel, as well as how many meters we had to drill. Then we did some simulations, of course, and I'll be going deeply into this, but we considered other properties of the explosive, as well as, for example, the density, the relative weight strength, which is a way to measure the energy which an explosive has, as well as different designs, because different explosives generate different designs. So number of boreholes were evaluated, burden, spacing, our stemming, our sub-drill was all evaluated, how much charge we had per hole, total charge of the holes, and then we did all of these calculations with O-Piteco, and we reached the end, and we had 3 different figures. So first figure with Hydromite 100, considering always more or less the same forwarding, we had an overall emission of 72 tons of CO2 on this blast. For the second scenario with Kemitti 510, we achieved a way less value of 40 tons, almost 41. And then for the third of Kemitti 810, we reached almost 48 tons. This being not only explosive, but explosive drilling, and as well as the initiation system here being the booster of forwarding. Of course, on the best scenario, we had a reduction of 44%. We will be explaining how it is possible to reach this reduction and what actually does it mean, this reduction. So going a little bit deeper into the model, we applied for the fragmentation a closed-ram model. We defined, as you can see on your screen, a target for our fragmentation of 500 millimeters, because we can't be reducing emissions if we are compromising fragmentation. Again, efficiency of operations is as important as environmental impacts are, so we need to get along. To make them get along, we need to always consider them both on a technical and environmental perspective. And then, of course, we had multiple factors that enter into this model, such as, again, the blast design dimensions, but not only. For example, we need to calculate the fragmentation, we need to establish our diameter, which for this specific setup was kept the same. So we had 102 millimeters for hole, which was quite big. We considered the rock factor average of 10, was not a very hard rock. And also our bench height was more or less 10 meters, and our volume per blast was 20,000 cubic meters. So not a very small blast, but not a very big one either. And then, of course, we for this operation, one of the things that we did was not consider drilling errors, but of course, drilling errors on an ideal, on a non-ideal operation are always to be considered, and will of course add even more emissions to our calculations. Then we had to do, by the cruise-ram model, we had to calculate the endpoints, which were the index of uniformity and the target fragmentation. And then we had to include the environmental data. And as soon as we did that, we considered the mass of explosive, we considered the emission factors with everything, production, transportation, charging, detonation. And then for the drilling machine, we considered all of the relevant inputs, such as power, such as the energy factor, the speed, and the emission factor, to then achieve both emissions of explosive as well as drilling. Then we combine them, and we have, as you can see again, the figure of 72 tons of CO2. If we compare explosives on a carbon footprint to carbon footprint basis, as you can see, Hydromite 100 since the beginning was clearly the worst. And because that is mainly related to the production. The production of Hydromite 100 is up to 2 times the production of KMT 510 and KMT 810. For this specific setup as well, we considered the drilling machine of FlexiRock D50. We didn't exchange the machine, we kept it the same for this study as the main focus was the explosives, but for future studies machines will also be altered as well, or will be changed, sorry. And then of course there were some inputs that we need to talk about, such as the energy conversion. Energy conversion is a way that we can say per kilogram of diesel or for liter of diesel we have X of kilowatts hour. In this case was a very low factor that to be considered due to the nature of these machines and due to the nature of these operations. Then again, fragmentation is important, and going specifically into the optimization model, we let the model choose the explosive and exchange the blast design ratios. Again, burden, spacing, stemming, subdrilling, and the number of boreholes. We demanded that the model kept the fragmentation and lowered the CO2 emissions as much as possible. And as you can see on the right screen, you can see that the whole fragmentation curves were kept more or less the same. Then we had to apply also some restrictions to the design, because on technical terms, on blast design, we cannot have, for example, a burden of negative values, for example, that does not exist. Also, we do not have negative stemming, and we do have, for this case, we applied ASH criteria for the blast design restrictions, but depending on site and depending on operation, such values can be exchanged within the model, and therefore you can do again the process of the optimization based on known field experience. Field experience will always be the best solution in order to optimize a blast. Then to translate this into numbers that you can actually see, because one thing is talking about kilograms of CO2, another thing is when we talk about what those kilograms of CO2 mean. If we translate that blast that we optimized to 22 blasts per year, if we do a direct comparison between the worst and the best scenario, if we are just to exchange the explosive today, 1 year from now, we would be saving what we call almost 759 tons of CO2. If you consider, for example, my car that travels every day 14 kilometers, which is almost more or less the exact distance I am currently from home. If I travel every single day during a year, my car will emit 1 ton of CO2, more or less, okay? And if it travels all of these days, 14 kilometers, with an emission factor of 244 grams per kilometer, this means that just by exchanging explosive, you will be taking 642 cars like mine off the road for a year. So it is very important, as you can see, that how we choose our explosives and how we apply our explosives, because in the end, after a year, it translates into these many cars. For example, another very, if we like to play with figures, we can translate this into trucks, we can translate this into people, we can translate this into houses, we can translate this into planes even. So it becomes quite funny what we can do with these figures. But as you can see, just by exchanging the explosive, we already saved all of these emissions. And this is how we optimize drill and blast operations, is on technical terms and on technical operations, then translated into environmental impacts. So now I'll be going again into the software itself. I'll be going how we can work with the software and how we can do an environmental impact report based on our own data. So just give me a second and I'll be exchanging exactly to the application. So I think you can already see my screen now. So working on the application, as you can see, and as I was saying, it is a web application, so it works directly on a browser. Currently I am on the Google Chrome browser, which was the base for all of this. And as you can see, I have 4 sections: overview, projects, database and results, and then of course my user profile. And as you can see right now, I am on a database and I already have some products that you can see, including the products that I use for the study. So for example, if I click here on Hydromite 100, the worst explosive on the study, I can see all of the environmental impacts related to this Hydromite 100, as you can see right here, from production all the way to transportation, charging and detonation. If you ask me where the data comes from, the data comes from environmental product declarations of the products. These are of course different from each factory and for each country as well. And depending on how we process this data, this can exchange, of course. Right now, we have a default database that is supplied by Norway Environmental Agency, which provides us with publicly available information. But as I was saying, you are able to introduce within a few clicks. For example, I'll be showing you how you can introduce your own data. So if you have another environmental agency or if you have another environmental product declaration, you can introduce that right here. For example, you can add a comment. For example, I'll say this comes from Portugal, for example. And then you can add, as you can see right here, your carbon footprint of the product. So if I do this whole process, it's as easy as you are seeing right here. Just have to add a couple figures. And then when you can no longer see, you just drag around, input the value for detonation, and then you have, simple as that, you have the carbon footprint for your bulk. Then if I want to compare my bulk to the other products I already have in the database, I do have a function right here called compare. Compare is especially very useful for when we are talking about marketing purposes, sustainability purposes, technical purposes. It is a tool that allows you to go all the way. And as you can see, my bulk A specifically has a special nin. In order to the rest of the explosives, it will be actually the worst. Of course, I did this on purpose to show to you exactly the compare function. And of course, if we were to say exactly which explosive right here has the lowest carbon footprint, it will actually be the explosive from our study, KBT 810. You can exchange this for other environmental impact categories as well. For example, stratospheric ozone layer depletion, tropospheric photochemical oxidants, acidification, for example, and so on and so on. So it is a very useful tool that you can use to compare your own products. There are other products that you can explore as well. We have some detonating cords here as well. We have some cartridges, we have some boosters, we have some detonators as well, as you can see right here, quite a lot of them. And you can do everything that I just did for every single category as well. Another thing that you can do on this database is that you can add trees. And I already prepared 3 trees right here. I have the O-Pitblast tree, which is essentially what we call a pine, which is translated to Portuguese is pinheiro. Few inputs that you can input here and are always publicly available within a few clicks in Google. You can see how much carbon the tree can sequestrate per year, and you can see as well how many years the tree will be doing such process. Usually this goes around 20 years. With everything that you see on this application, except for the trees, is controlled by our lifecycle editor. Before this presentation, I prepared this lifecycle for exactly the explosives application. And this allows me to control everything within my categories, so I can control every single product from here and decide if they are to be considered or not. Then moving forward, you go into projects, and I already prepared here a project for you today. As you can see, I have my Blast A and my Blast B, and when I go into Blast A and Blast B, I'll go into Blast B, you can see that I have a couple of details I can fulfill. So first of all, you can edit your own blast with name, owner, and you can also edit the date. So here, for example, my date would be today, 6th of July. Then you can edit blast properties, such as the number of boreholes, volume of production, diameter of borehole, burden, spacing, sub-drilling, stemming, and bench height. You can control them right here. And if you want to input, for example, let's say I had 80 holes, I had a volume of production of 10,000, for example. I had a diameter of 802, just as the study. Burden of 3, spacing 3, sorry, mistyped. Sub-drilling of 1, stemming of 3, and bench height of 12, for example. As soon as I apply, you can see all of the values update, and you have all of your information stored within the blast. Then you have 4 sections in which you can work with: drilling, trucks, charging, and initiation systems. Here on charging, I already prepared an explosive for you, and I'll be adding another. So let's say I used 2 explosives. I used KMT 510 and KMT 810 on this specific blast. So I had 4,000 kilograms of KMTs into this blast. On the initiation systems, let's say for example, and let's put the Fording that I had before. Let's say I had 80 units or 80 kilograms of Fording. Let's say I had, let's say for example, let me get a cord. Let's say I used 80 units of this cord as well. It is as easy as you see. You can register this, and then it will always sum up and tell you how many products you have, how many units you have, how much is your charge as well. And then when you go back, I don't even have to go into the reports to see the emission, total emission for the blast, to see the last modification I did to the blast, when did I create the blast, and when was the date of the blast as well. Following steps is going into reports, and when I go into reports and I report everything I have on the application, as you can see, I have not only the total the total carbon footprint, I have total explosives I used, volume of production, total meters drilled if you are to input that, number of boreholes, how many blasts I selected, how many projects I have. Then I have on this first chart a carbon footprint described per stage. As you can see, I have production, detonation, charging, and transportation for this. If I am to consider, for example, my O-Pitblast tree, only for this project I would have to plant more than 1,000 trees, just for this project. If I also want, I can translate this into carbon credits as well. And for this project, within location, if I am to consider, for California, I have $1,000, for New Zealand I have 600, for Europe I have 300, and for Korea I will have almost $2,000 just on carbon emissions for this project. Then I can translate all of this data into a report, and as you can see, I have everything from my charging setups with all of the environmental categories being considered. And as you can see, this is divided into 2, so that you can have a more clear and precise way of the information. And then the same thing applies for initiation systems as well. So Fording and right now. Let's say now, and let's jump back to the charging, for example. Let's say you want to print this as a PDF. So you press on the print. As you can see, I have the full report right here. And then I can choose if I want, for example, I could print this right away at our printer. I could save it as PDF, or even have more options. Send by email, send by WhatsApp, send by LinkedIn, send it through every single system that you might think of. You can also decide if you want all pages, if you don't want all pages, if you want all of the copies, if you don't want all of the copies. You can see already I will take 3 sheets of paper. It has been a thing that we have introduced so that people also, of course, as being a sustainable application, we do need to also consider the emissions that we have on printing paper. You can customize the layout, you can customize the color if you want colors, if you want black and white. Myself, I always print on black and white. Then you have more settings as well. You can transform the whole paper if you want a whole page, if you want half a page. Usually I print very big reports, so this comes very handful in order to, again, optimize the paper as much as we can. How many pages I want per sheet, if I want minimum margins, big margins, small margins, the scale that I want as well, if I want it to be printed on both sides, if I want it flipped on long edge, short edge, if I want the headers and the footers, if I don't want the headers and the footers, if I only want the tables, if I want background graphics, yes or no, if I want to print this on a PDF on preview, yes or no. And then you have full the options for you to explore and use it as the best as you can. Then the final stage of the application is the overview, and as you can see, you are immediately faced with every single value for your operation. How much explosives you used, carbon footprint, here CFCs were way too low to be shown, tropospheric photochemical oxidants translated into kilograms of ethane, acidification of land and water, eutrophication, abolition for non-fossil, abolition depletion for fossil resources, as you can see a very big number on energy. Then I have right here the global warming per life cycle stage, and I can translate it immediately into production, into transportation, into charging and detonation. Then I can compare, as you can see right here, I can compare this directly, blast per blast as well, and I can see right from here, from blast A to blast B. Blast B would be the biggest one. And then you can also translate this into green area, carbon credits, and so on. So this is the final step of the application, where you can take overall figures to use them on all of your presentations. So for the application, I think this would be more or less it. Right now I'll be jumping to the end of this webinar and to the end of this presentation. If you have any questions, please feel free again to write them in chat. We will be answering them shortly. And right now I will be sitting right next here to answer all of your questions. Thank you again for your time and for assisting this webinar, and I'll be passing over to Sarah.
Hello everyone, I'm gonna join Fabio now. He's gonna answer a few questions that you've made. We have a question from Fatima, which is, which other fragmentation models are you considering implementing in the software?
So for now, it was actually on the case study, we started with COSRAM model because it's the most applied model in the industry, but we are considering Swedish models as well. And other specific models, not only empirical, but also models that depend directly on numerical analysis as well. So further models will be tested in order to have different optimizations as well. I think we have another question right here.
Adam, you made a comment and a question.
Another question, yeah.
So I'm going to read it to you. As you probably know, lately many new developments of green explosives started to appear in the market. And as you mentioned, manufacturing of explosives contributes 90% to all emissions of DNB. If we imagine that in the future all operations will transition to eco-explosives with zero emissions in production stage, then wouldn't it be enough to close the question of DNB-related emissions?
So, Adam, unfortunately, no. That would be, I think, ideal scenario, but we work on a very non-ideal world. And here I talked a lot about explosives, but not only is zero emissions in production stage a thing that it's almost impossible to achieve due to the nature of the production stage emissions. For example, even if we decrease the main part of ammonium nitrate production, if we replace it with green ammonia, we still have to care of how this will be transported, how this will be stored. For example, and all of these processes, due to chemical reasons, have CO2 emissions. So net zero here will be very hard to reach, of course. Not only that, on drilling, for example, we do have fuel consumption. And currently, everything is being either electric or fuel. Electricity is different, of course, from fuel consumption, has way less emissions, but has emissions that are then translated in how we get this electricity. And for now, depending on countries, and even on the best countries on sustainability terms, we do still have a large footprint on for example, coal usage, fuel usage to produce electricity. So again, we have always carbon emissions. So unfortunately, it wouldn't be enough to close the question on drill and blast related emissions. Plus, all of these technologies, green technologies, are at the beginning of their process in order to be not only affordable products, but technically validated products as well. We need to care about what we do meanwhile. So meanwhile, the only thing that we can do as end users is optimize the way that we use our explosives and our machines the best that we can to reduce emissions as much as we can, so that we can optimize operations as much as we can, and therefore reducing costs, improving profitability, and reducing environmental impacts. I hope I have answered your question.
Another question from Amaro is, can we input our own data into the software? Where can we find this kind of environmental information?
So, as I've shown on the software, you can input your own data with your own methods of calculation into the software. It works with the end result, so the emission factor. Follows as well the international model, which is not a very complicated thing to explain. So it works based on emission factor and the quantity of explosive that you have, for example. And then where you can find this kind of environmental information is on environmental portals. For example, the values that we have on the database, default database for O-Piteco, are all provided by the Norwich Association for Environmental Product Declarations. But for example, in France, they have their own association that provides to their end users these environmental product declarations as well. So it depends on which country you are, but all of this data on best scenario will always come for environmental product declarations.
From Marius, does the software only focus on the gases that that are produced during the blasting operation, or does it also calculate the respirable dust that is liberated? In SA, this is a big problem.
So on first version, we are only considering the gases that are producing during the blast operation and before. So on the whole cycle, we are considering production, transportation, charging, and detonation. So we are mainly talking about those gases. Respirable dust is a thing that has been on our plans for a while, not only for environmental reasons, but also for safety reasons. As I was saying, safety reasons is also very, very important. So it is expected in the future that we have some kind of integration with a monitoring system in order to do exactly not only the prediction, but also the monitoring of dust that is being elaborated in quarries, mines, underground mines, open cut mines.
One more question from Mani. There is no option of air deck length. Air decking can be a vital technique to reduce CO2 emissions. Not really a question.
Yes, yes, exactly. It's a very good point. So on the first version, we cannot add not only air decks, but decks themselves. It will come on the second version when we add the accessory tab. So you can input not only the air deck and the air deck length, but actually you can input the reverse of what we call the carbon footprint. It's no longer a carbon footprint, but it's how much you can reduce. So it will be a technology that you can apply in order to reduce the carbon emission. It will come on a future version.
And I believe we have more questions coming from Frank. Are there discussions with the explosives manufacturers to fill the database?
Yes, it is not only more than that. Here on Europe, and we are a part of the European Federal Explosives Association, which we, just to take a moment, we will be there in Dublin for the event. So if anyone is looking to go there, you can find us there. Not only are we discussing with the explosive manufacturers to fill a public database, not only to us, but to everyone, but as well we are talking with them for them to do their own environmental product declarations, because that is, I think, the best way for us to approach this, because we already have the system in place. The only thing that we need is the data. So if we are to cooperate, we all earn. The manufacturers earn, we earn, and everybody earns. So that is for sure the best way. And yes, we are in talks.
All right, I believe there's no more questions.
Now there's one right there. Just if you pull it from...
Oh, yes, I will answer that from Hervé. Sorry if I mispronounced your name. We are at the end of our webinar from O-Piteco. I hope Fabio was clear. And you can also ask all the questions you want. Raquel left on the comments our emails. And Hervé, for you, you can go to our website or contact our team directly. But we can all go to our website and you can ask a free trial for our O-Piteco. You have a whole page with all the information that you need for O-Piteco, the brochures, the video, the free trial request, and you can also contact our team directly from there. So thank you very much. I hope everything was clear, and don't forget we are always here to answer your questions, webinar or not. So contact us very soon. We will send you all the presentations that were made here from the people who subscribed to the webinar. And if you didn't subscribe but you want these presentations that Fabio made, please contact us and we will send it to you from our website, for our team. Wherever you decided, we will send it to you. So thank you very much. We are O-Pitblast and this was the O-Piteco webinar.
Thank you a lot, guys.
I'll see you next time. Stay tuned to all O-Pitblast pages.
Thank you.